Welcome to the Troopers Day number 2. I'm Christian, that's Daniel, and we will show you a little bit about open source monitoring and some security issues about that. We have just little topics on the agenda. First, just 2 slides who we are, which software we used, the results, a demo, responses and mitigations, of course. Deutsche Telekom is a quite huge company. We are working in at least, I think, 50 countries worldwide. We have broadband access, mobile, and also fixed line stuff, and also IPTV customers. The area we come from is the group information security area. We are responsible for security requirements. We have the third team in that, abuse team, testing, and so on. Open source monitoring software. Nowadays, such kind of software is critical for the administrators, for the daily business that they are doing. They give an end-to-end view to the network and also a detailed view to the hardware as well. The main focus we are for the availability tools, such running the administrators. All functions or all solutions we have discovered are in common. They are agent-based. That means that the central monitoring system will access to the network elements and to the servers. And they are web-based. Out of scope are such tools like...
Second, Michael will be here in 5 minutes. So
okay, we have already started. Out of scope are security monitoring tools, commercial tools, also intrusion detection, intrusion protection tools.
Ta-da. Well, yeah, what are the threats to open source or general monitoring software as we use them in networks? Well, apparently, first of all, it's a ubiquitous component. You see them everywhere. I guess all of you have some kind of, or any means, any means of monitoring in a network. Might be something like Bro, which is more or less security networking, but anyhow. But also Nagios, Cacti, things like that. I guess you've all heard of them. You see them actually everywhere. Also, per se, those solutions are centralized solutions. I mean, they have to monitor multiple networks, so that's why you use them. Which means usually those solutions are, the position in the network is pretty deep, as in closer to the admin network, not near the internet, but rather in the internal network. And that's interesting. From the attacker point of view, that's interesting, right? And it's used in almost all the environments you have out there. It could be a home network, it could be definitely enterprise networks, ISPs, telcos, everywhere. So what's so interesting about, what's so special about attacks against monitoring software? Well, first of all, as I said before, location. The location of the monitoring solutions are interesting. But also brings up new attack vectors or new attack possibilities. We came up with a super cool acronym. That's MTAACA and CTAMTAACA. What the hell does that mean? Well, that's simple. It means machines that act as clients attacks and clients that access machines that act as clients attacks. And you have no idea what I'm talking about, but it really makes sense after the demonstration. It's just a different way how to attack applications and the way how machines are interconnected. Well, as I said before, the risks are a monitoring software apparently is a more valuable target because of the location and the access to different networks and systems. And also, the monitoring software usually does a lot of input data parsing. Again, Bro is a good example for that. But you have to parse log files, SNMP traps, all that information you get in, you have to parse and display in any way. All of them use web GUIs, which is pretty interesting. Well, at least the one we had a look at, which brings up like a whole new bunch of possible bugs, like the OS top 10. And actually, that's what we found mainly in all of the applications. And also, you have some homebrew agents on every system. Quite frankly, I don't like the idea of installing agents on a system, but sometimes this is necessary to monitor those systems. Not a good gut feeling, I don't know. And also, as I said before, location is interesting. it has potential access to a lot of networks and systems you wouldn't see otherwise if you were to attack a system from the internet or in the DMZ or whatever. So that apparent risks when you attack networking software.
Okay, let's have a quick view how the monitoring software is typically implemented in any network. We have, of course, a lot of admins. The admins normally use a web client, a browser, whatever, to access the central monitoring system we have discovered. Such system has, of course, access to a lot of network elements within your network. That can be firewalls, routers, switches, access points, whatever. They use agent-based SMNP as well, of course. And also, the same monitoring system has access to any services within your network, web server, file server, DNS server. And mostly in any networks, you have also access via own checks, self-written checks, for example, to application server, to a VPN gateway, to a backup system, whatever. Also, this system will be used to get information from network elements in other offices, factories, branches. And within these branches, you have also guys or administrators that are calling back or connecting back to the central monitoring system.
Ooh. All right, so what do we cover here? Well, first of all, and that's really important to us, this is not an academic talk. So we're not talking about the potential attacks or something that could happen out there, but rather what's really exploitable. And you would see at the end, it's something we learned from what we've seen out there, and we actually use every day. Why open source? Well, open source is kind of easy to audit. That really depends on the code quality, but I mean, it's kind of something you can do on your own. You can just have a look into the source code and see if there's any security bugs, right? Just to make sure, we don't want to point out that open source is less secure than closed source. It's just the approach we had and why it was easier to us to actually audit this kind of software. Apparently, yeah, everyone has at least a chance to make sure that there's the software you're using, especially this kind of software, is kind of secure, right? And also we focused on market leading and the industry standard software solutions. We'll later see a list of what we had to look into. That was important to us. We did not cover, as I mentioned earlier, closed source or commercial solutions, but that was just like a random decision. We might do this in the future, not sure. We did not inspect any architectural software flaws because there's quite some in them. And also stuff like checking of SSL certificates. Don't get me into this, it's pretty bad. We didn't have a look into this, so we were actually just looking, is the software, the component secure, as in secure programmed. We didn't have any look into critical features, stuff like, oh, I have a centralized monitoring system and I allow this system to execute any random command on my target systems. That's a no-go, and apparently this is not recommended, but still, you have this functionality, but that's a security problem per se, so we didn't have a look into that either. We did not have a look into additional plugins or features or add-ons, because you have like a zillion plugins. Those could be buggy, and that's not fair. I mean, it's not fair to blame a buggy add-on or plugin and blame the open source software to be insecure. Anyhow, we have a look at one plugin, but that plugin is a very special one, so it'll bear with me. We'll see later. But we didn't have a look into this in general. And also, we didn't have a look into the agents. They might be insecure. Again, we didn't have the time for that. We might do this in the future.
Tools we discovered is such a bunch, we say, market leaders, well-known tools. I have just impressed some phrases from their own homepages. So Cacti is, of course, an open source, well-known monitoring system. It graphs a lot of the CPU usage, of the interface usage of routers, at least with SMNP. Nagios is, of course, the industry standard. Everyone uses, I think. Checkmcar is quite interesting. It's mainly an add-on, but it's quite interesting from our perspective. It's nearly an own solution. They have an own agent, they have an own configuration management about that, they have an own logic behind that, an own overview, web browser, web overview. And Insinga is also based on Nagios, but is also quite interesting from the wide range of use within the networks. Also, so quite interesting is it's nearly placed deep in your network, and just 2 of the 4 tools gives you the opportunity to load it from a HTTPS secured website. All others are plain HTTP, and we have seen in the telco sector at least the DNS stuff, all those fine things are running there, or DNS poisoning. Also, we have discovered well-known incidents in the last years. There was a remote buffer overflow within Nagios in end of 2012. Also interesting is the Hetzner case. It's unfortunately only in Germany available, or in German. The English translated articles are not longer available within the internet. So quite interesting that a central Nagios system was compromised with a rootkit.
So what are the results? Well, the results, we actually found critical issues in all of the solutions. Critical issues as in memory corruption, buffer heap overflows, off-by-ones, cross-site request forgery, cross-site scripting, remote code execution, arbitrary file access, like all of it pretty much. And also actually we found many web-based bugs, which is pretty interesting because this is actually what we had to look into. Just to clarify this, we found some buffer overflows, but they're pretty hard to exploit on modern systems. Yet they're still in there. Well, they're fixed now, but they have been in there. But exploiting buffer overflow is not as reliable as exploiting a web-based bug. So we actually focused on that one. And yeah.
I think that's a quite short overview about the versions we use and so on. The main interesting part from my side is the row with the number of open findings, where we still have a lot one, or they are not currently not fixed by the vendors. So I will skip the slides. You can read it, of course, later. So, can we get a shell on such system?
All right. So, what we're trying to display here is what are the potential attacks that could occur with those bugs we found. We set up a virtualized sample network just to make sure, so what are the potential ways. We chose this onion because usually you have this kind of network security. You have an onion, you have like the inner part, which is, in this case, it's the admin network, and you have a monitoring network and a DMZ and the internet. And yeah, we're trying to actually, we set up an environment like this. So over here, this is the hacker. That's me. We have a DMZ, and you will later see this is one of those systems being monitored by the monitoring solutions. In the monitoring network, we have Cacti and OMD. OMD is an open source, like a bundle of monitoring software, which is pretty convenient, pretty neat to use because it's all pre-packaged and you can just install it and use it, and that's cool. And you have the admin network.
That's me.
That's him. I'm the good guy. He's a good guy. I'm the bad guy. All right. What are the assumptions? So first of all, we're trying to cover default installations. It doesn't really make sense if we change, tweaked all the configuration that way that we could exploit very, very niche bugs. So it's the default installation, no big configuration, no plugins. As I mentioned before, we will not look into the insecure by architecture bugs, something like the way how the systems communicate. We didn't set up a fake network, and this is really important. I really, really, really hate those presentations where you see an attack and you're like, well, okay, this is really bad, but you would see this kind of network only in the researcher's lab. I've seen so many presentations where everyone says SSL is broken and crypto is broken and everything. Well, why the fuck do you not break every system out there? I mean, seriously. So that was the idea. The environment should not be fake. So first box, and here are the shells. Now we see some shells, some ODs, so that's fun. First box is Cacti. Does everyone know Cacti? This is like standard
in your
solution.
network?
So the box we're looking into here is, first of all, cross-site request forgery, and exec-like functions being called with an untrusted input. Does anyone not know what cross-site request forgery is? It's a web-based bug. Okay, cool, because it's important to understand. All right, I guess I need the admin to log in.
Of course.
So what's the problem here? Cacti has a couple of configurations you can set up. And one of them is you can fill in a username in a functionality that's called graph export. What it does is actually export graphs onto an external system, like an FTP server.
So I logged in. Okay. I logged in as an administrator. It does well. It's quite interesting. You can find on the configuration menu the settings part and also the graph export part. Any user who has access to the graph export are vulnerable against that, what we'll see later. So quite interesting is we have disabled the.
Can you enlarge the window a little bit?
No.
No.
I don't know. So we can.
Kannst die Schrift größer machen?
Such better. We will use the graph export.
Yeah. So the idea is actually you fill in information as the FTP username, which is being down there on this side, and the cross-site request forgery gets executed when the admin serves a website or clicks on a link, or visits a malicious website, something that the hacker I did set up. So how does it look like? Right. So I'm the hacker. That's good. So to exploit this, I need to know the URL of the Cacti installation. I know this is bad, but this is how it works. So I need the URL of the Cacti installation because that's where the cross-site request forgery gets triggered. So I set up a web server, and I'm waiting for the admin to surf the internet and visit my website or click on a link. And that's what he just did. And now I'm starting a handler, and this handler is actually just waiting for a back connect shell. It takes about a couple of seconds, and here we go. So as you can see, hostname, I'm on the Cacti system. That is not good. Well, as we can see, if we have a look into the configuration, if we refresh this, right now we have the change of the setting.
Yeah. The FTP is enabled, and also we have filled in some stuff within the FTP user field.
So first shell. All right. So what we actually did is from the internet, we attacked a monitoring system. Neat. So what are the pros and the cons? When I say pro, I mean, of course, pro as an attacker and con as an attacker. The pro is we have shell. That's awesome. And that's pretty much it. The cons are, well, I need to know the Cacti installation URL, which is kind of annoying. I mean, sometimes it's not a secret, but still. The admin needs to access a link or a website. Outgoing connections may be restricted. And the admin needs to be logged in. Not really. why not really? I mean, as we saw before, apparently he has to be logged in because that's how cross-site request forgery works. But there's another attack. What if the administrator logs out?
So I will clean up the installation. I will disable that and will also clean up the field here.
Delete this. No. That's secret.
So I will save this. And I also will log out to the monitoring system.
So he's logged out. Once again, I start another exploit and trying to trick the admin to visit my site. What's happening now is trying to brute force. Because I have the URL, I can try and brute force that. I think this time it's not working. Oh, it is. And that was it. To wait for a second. Does anyone know where the quote is from? Yes, yes. Does anyone, the other quote? Dave, I'm afraid I can't do that. Yeah, you do. That was Hell from 2001. This is Star Wars. Waiting. Could take up to a minute. Because what happens is actually it's a cron job. The export is a cron job, so it only gets triggered once every minute. In the meantime, you can have a look into Cacti and see if you're logged in.
Yep.
Yeah, there you go. So now he's logged in. He never logged in, but apparently I brute forced the password. As you can see, I brute forced kind of, I think, 100, 200 passwords in a couple of seconds. If that website were to show some cat with video or something like that, and I have like 5 minutes, I can brute force thousands of logins. Awesome, shell. All right, so that was Cacti. We find a couple more bugs, but this is the most interesting. But yeah, I mean, you need to know the URL. This is not really fancy. This is just a simple cross-site request forgery, right? So here's the next thing, checkmk. Checkmk is a plugin for Nagios. And it has a couple of bugs as well. It does, again, have a cross-site request forgery bug. It does have exec-like functions being called on untrusted input. And that's a real neat one. And we're trying to exploit the cross-site scripting. It's getting interesting there, trust me. So checkmk. Could the admin please log in and checkmk? This is how it looks like. So it's just like a simple dashboard, and you get all the warnings and the host being monitored. checkmk has one functionality, and that is it's called snapshots. It's more or less just a backup, so you can back up your configuration and restore it. And
I can show it. It's the web administration tool, Veto, and you have here the backup and restore function.
So as you can see, you have a snapshot. You can also upload a snapshot. Again, if you have cross-site request forgery, you can upload a snapshot. What does it mean? Well, snapshots, when they get uploaded and unpacked, you can, by the way, this uploading can be achieved due to missing cross-site request forgery tokens. And after the upload, it's not just a snapshot, but it gets executed. So the snapshot is pure Python code, which is neat because I can build complex payloads. It gets executed as soon as the snapshot is unpacked. So again, this is pretty straightforward. We have the functionality. All I have to do is set up a website, craft a special payload, trigger the admin, trick the admin to visit my website, upload this payload, trigger this upload, and trigger another URL, and after that, I have actually a Python shell. How does that look like? Again, for that, I need the URL. As we can see up there. So yeah, I'm starting my exploit. Actually, the same as before. I set up a website. I trick the admin. to visit my website. You know that quote? Yeah, you do. You should know. Yeah, excellent, yes. And here's my shell. That's much quicker than before because I don't have to wait for the cron job. Another shell. Again, I'm on the monitoring system. Yay, shell. But that's more or less the same as we had before. Again, the pro is shell. And it's a persistent shell. I mean, I can just write anything on the file system. I have Python code. I can do whatever I want. The con, I need to know the URL of checkmk. This could be hard. Like this is information it could be hard to get. The admin needs to access a link or a site. Still, he has to visit a website where this bug gets triggered. The admin has to be logged in. And outgoing connections may be restricted. As we've seen before, if you have a secure network, which you all do, of course, the connection, I'm having a connection from the monitoring network to the internet. There should be firewalls between there, and there are firewalls. But there's one connection that's trusted. And that's the connection from the monitoring system to the system which is being monitored. And that's one of the systems in DNZ. So I can use that connection. I can use that connection, but also I still need the URL of checkmk. Again, this is something I don't necessarily have, this information. But we can do better. Because what gets displayed on all the installations, we'll see later, there's a special string, and I can use this crossout scripting. Crossout scripting triggers the snapshot features. And what gets displayed is always the agent string. We can have a look at that.
Of course. You can see the host and the...
And up there, that's an agent string.
Up there, that's the agent string.
That's hard-coded in the agent on the target system and gets displayed. Well, unfortunately, it gets displayed without any encoding. And also, we can reuse the connection. As I said before, there's a connection from the monitoring system to the system which is being monitored, which does have a connection to the internet. I don't need, actually, I can bypass all the firewalls because there are rules for that, right? So, what do we need? Well, apparently, I have to modify the agent. How can we do that? Well, I can try and break into a system being monitored and check and change that agent string. And this is actually exactly what we're doing right now. So let's say I know about the system in the interwebs, which is being monitored by some random company. And I'm scanning the network. In this case, this IP address, the 10.0.99.70. And what comes up? Taking a while. It's only port 22 open. So logic conclusion, brute force, of course. Let's try and break this one. So what I'm doing right now is brute forcing a system which is exposed to the internet. That happens all the time, right? Takes a while. And it should have some secure password, but 1, 2, 3, 4, 5, 6, that's the root password. Awesome. Again, I mean, the fact that a system which is facing the internet is being hacked, that happens all the time. So as the hacker, I know how to get on the system. Neat. So I'm on the system, and let's just check. Apparently, I do have two interfaces. And that's, I mean, apparently, I have one interface to the internet and one to the monitoring network. Right here, this is the internal IP address. But still, how can I use that information to trigger a bug in the back end? Well, as I said, change the agent string in checkmk agent, which is just a shell script. And of course, I need the IP address of the internal interface, because what I'm doing is actually I'm triggering shellcode executed on checkmk, taking the back connection, using this system as a proxy and proxying this out to the internet. So I need to know this internal IP address. I hope that makes sense. So when I start the exploit, it spits out the information I have to enter, how I have to modify the checkmk agent. And that's what I'm doing right now. Just replace this string, and that's just a cross-out scripting I'm triggering here. And also enter this. So what this does is waiting for a certain connection string. So the checkmk agent is running, is waiting for a certain connection string. If that shows up, it will proxy the connection out to the internet. If it doesn't show up within 0.5 seconds, it'll just spit out the usual checkmk information. So the app administrator will never actually see any change. It still shows up as a functional system. It's all good. But we have shell, as you will see. All right. So again, it's taken a while till this updates, but we can force it. Yeah. Oh. Ah, is it a timeout? Something given. So apparently this is a timeout. This happens because nochmal. This happens because in the meanwhile, checkmk tries to update the dashboard. And I have to change the username's password. It's a bit complicated, but this is how it works. Das sind die ganzen Ajax-Codes. Machen wir weiter. Okay, wenn es nicht geht, dann überspringen wir den.
Just close the site one time.
Yeah, this should work.
We log in.
It did work on Tuesday. Yeah. It doesn't work now. So I think my idea would be skip that one and put it at the end, because there's actually more interesting coming up now. I get to this bit later.
That's part of a live demo.
Yeah. Well, we're kind of running out of time, so I'm trying to skip that one. So the pro, if it works, is again, we have shell. We have a persistent shell. I don't need to know the URL as it is in browser. I can use an existing connection for an outgoing connection, for an outgoing shell. It's only get triggered when the admin logs in, apparently, because that's when the agent string is being displayed, right? The cons is we need root access on that monitored system. You don't always have that. So what if owning the system, as I did before, is not an option? because some of them are hardened. And this is actually what we're doing later. We will harden the target system. 1, 2, 3, 4, 5, 6 is not a good password. You use SSH keys, right? But here's the fun thing. We can own the system without knowing the URL, without knowing anything, with just one SSH attempt, even if a public key is configured. And why is that? Well, it's a cross-site scripting in the username of the SSH connection. And now Mary clarifies what I mentioned earlier. This attack triggers a cross-site scripting that triggers a cross-site request forgery, that triggers an upload, that triggers a shell. So it's actually a multiple, it's a chain of exploits more or less. But I never really attack the admin, and I never attack the target system. I attack the functionality of an admin using the monitoring system. We need Logwatch for that. Logwatch is actually just one more plugin or a functionality that watches log files. And this is actually something you do on a daily basis when you do monitoring, right? And the default installation will do. Again, I've installed this. I did not change a single line in the configuration. This is the default installation. As I mentioned earlier, the cross-site scripting gets triggered by a specially crafted SSH connection string, which contains JavaScript. And the old farts, old hackers in here might remember a similar bug. And that bug was disclosed more than 10 years ago by H.D. Moore. And what H.D. Moore actually did was he found out about escape. What's the name? Escape characters. So what he found out is actually if you watch a log or something, any terminal emulation, and it has certain characters in there, you may be able to execute code. And it's an interesting article. As you can see, it's over 10 years old. But in the whole article, you can just replace terminal emulator with browser, because this is what we use nowadays. We don't use terminals, we use browsers. And the same bugs, which are 10 years old, are still valid. So how does that work? I think what I'm doing right now is I'm restoring the systems just to make sure we're starting from scratch. And the next step is actually the administrator, being a good administrator, hardens the target system. So what I did earlier, brute forcing should not be feasible, right? We do that by permitting only SSH public key based authentication.
Okay. To log onto the target system, I get the root rights, of course. Then I get access to the SSH daemon configuration. That's not still there. Oh, no, of course. I still
You
miss.
need an editor for that.
Yep. I get the right term where the password authentication is currently enabled. I disable that, of course. And I restart one time the SSH daemon. So now I'm protected by the key.
I tried this again. I tried to log in as root. Connection refused.
Again. It's not open. We want to restart the machine again? The target?
That admin knows jack shit about administration, apparently.
Let's try again. No.
Müssen wir zurücksetzen?
Yeah. We try to reset the virtual machine. Again, I get access to the virtual machine. I will change the SSH daemon configuration. But I need, of course, administrator rights to do that.
Yeah. Klein, schreib's klein.
And I restart the daemon again.
Yeah, so apparently now I do not have access because I need a public key, right? And that's a good thing from the admin point of view. Well, what if we exploit the cross-site scripting? So what I'm doing right now, I'm starting the exploit. I don't need any information, not an URL, not an IP address, nothing. It spits out the information I have to enter on my system. That's connecting to the target system with a string. You should log in as the admin.
I now log out from the target system and also start the Firefox.
Right, so all's cool, nothing happened. And that was it. Not really exciting, isn't it? But I just have to wait. Because what I just did is I'm injecting cross-site scripting or JavaScript code on this website. And there you are. What it does is triggering exactly what I've seen before. It'll upload the snapshot, it'll upload the payload, and there's my shell. Cheers. So what does that mean? That was just an SSH connection attempt. It's all default. I didn't change anything. That's the default installation. The pro, we got shell.
Thanks, Philip.
And it's Philippe approved. It's ultra stealth. I mean, this one shows up because I want to make it really obvious, but I don't have to. There's no need to know the URL beforehand at all, any. It only triggers when the admin logs in, right? And the con is, well, still we need outgoing connections, but you could use DNS or SMP tunnels, or you could use the trick I showed before, using the interim server, the proxy server. So here's an evil one. What if I spit out this string out to the interwebs on port 22 and set up a website and waiting for those shells popping up? Because this is all I have to do. I just spit out the string, and it should be fixed by now, but not necessarily be patched on all the systems out there. Well, and the result is profit, apparently. And that was the demo part. Now back to the mitigation.
Okay, so after we have found such flows, we are already connecting the developers. That's quite interesting because a lot of the developers doesn't offer you a chance to give them the information in a private way. So a lot of them have only a public mailing list available where you can trigger, but I think it's not a good case to print out such problems on the public mailing list always. We found, of course, a lot of email addresses in the DNS registries, on demonstrations and presentations on any conferences, so we are able to get in contact with the developers. There's just one solution, Itzinga. They're the only one they offer a private way to give him, or you can send in private information to the developers. The timeline is also an interesting part in this case, I think. One of the solutions needs just about 6 days to fix all of the problems and provide a new release. Another solution needs up to 85 days to fix it. And until now, unfortunately, there are two solutions that doesn't provide any update until now. What we will do after the conference here, the Troopers, we will publish all of the information about the flaws.
My favorite.
Enjoyed.
So what's the feedback we got? I mean, we're talking about software we all use in our networks, right? This is sensitive stuff somehow, I guess. So what's the feedback from the developers? Well, most impressive, what's OWASP? That's 2014. They didn't even know it existed. Or there's something like security guideline. That's cool. I've never seen that. But they sell this. So they sell consultancies and support contracts. That's important. Well, yeah. What you found is a feature. Yes, and it's also a backdoor, as you can see. But they call it a feature. My favorite, what tools did you use for scanning? We did not scan. It's open source. We did have a look into the source code, and we found bugs. We did not use any scanners or fancy proxy scanners, burp, whatever. Why? And that's really terrible. Why should we fix what you see as a security problem? We never asked for this audit. Yes, exactly. That was my reply. What the hell? So that's kind of right, but I mean, it's open source. I can audit my source code as much as I like, and I can report bugs, and I do it in the future. I will. Why not? And also, we had no response at all. So some of them didn't reply at all. Apparently, were not interested or didn't see it as a security problem. We won't name any companies because we don't want to bash too hard on them, but yeah, that's what happens.
Yeah, unfortunately, in any tools, you can't find now no information about any security flaws. They have no change releases that trigger that out. They have no information on the website that triggers out. If an admin doesn't look like for a new function, he already wants the old vulnerable version of the system. Also, credits, what's that? We find any flaws, we find any security issues with those solutions. Why we pointed out it's done by anyone. It makes no sense, of course. The only one they are already professional going with this flaws is a Singer team. They have fixed it really quickly. They have included the fixes to the backports to the older versions, and they have ordering CVE numbers and print it out, make it public. So that's the only solution they do it in a professional way with such flaws. To make it broken is not the only way. I think we try to fix it to make the world a safer place, as Sendo means a lot of time. One is to consider the guidelines we are founding for the solutions. They are for Nagios and in Singer available. They are, for example, also pointing such things if you write on checks, take an input validation and so on. Of course, the general basics you already know, passwords. Don't use default passwords. We have shown the demo. We can brute force this remotely without access to the system. Minimal writes on the application, hardening, of course, and also if it doesn't need such a feature like the veto on the check-in car, remove it, disable it. Also on the network level, you can do a lot to mitigate such risks. put your systems not flat in the corporate network. Use a firewall system or firewall before the system to check it. Also, consider to segregate function-based monitoring system, so that's not you have one central system to get access to all of your network elements. And yeah, unfortunately, no internet for the monitoring system and for the administrator workstations as well. That means include no DNS and no ICMP. And also on the application level, you can segregate this, of course. With roles, consider that the rights are placed in the manner that the triggers are not can be done. Another problem we have is also the agents they are used to get the information from the system. You need, of course, privileges. We have other agents out of scope, but there should be also another discussion to check it out. One of the vendors consider to make the checks over SSH daemon. You must be configured carefully because then otherwise you get a direct shell from the or attacker get a direct shell to their target systems. And one solution we also have identified is change the communication between the central system and the agent. That means that when anyone compromises your central monitoring system, he is not able to get access to all connecting network elements, servers, and so on. Within the CheckMK agent or solution, you can do this without install anything. It's just a configuration. It looks quite easy. Run the CheckMK agent not remotely over a TCP socket. Take it in locally on your system, put the output into a file, transfer the file via a secure solution like SFTP, SFTP to your central monitoring system, and the central monitoring system will check the information and gather the graphs and make what it did monitoring. In this case, you will see your network architecture looks much better like the other one, and if you consider all of the hardening part, it might be a more secure monitoring solution as before. Conclusion. Take care about what you use in your network. Take care about where you get the sources for the software, of course. When you use open source software, it doesn't mean it's secure itself, of course. In general, open source more or less or secure than commercial solutions. Isolate the administrators, take it off the internet, of course, and for the developers, yeah, check the OWASP stuff. Okay, thank you.
Cheers.